All right, welcome to your Algebra 3 final review videos, numbers 14, 15, 16, and 17. I'm going to be real with you. These ones are going to be a little weird because you have to solve by graphing. And to be quite honest with you, I can't graph on your TI calculators right here. This is not going to work. But I'm going to explain to you what you should do. And then if you still have questions, you should, talk to me or your teacher or somebody who does math. So this one, we're finding the real solutions of the equation by graphing. What I would do for this one, on your calculator, I would click the y equals button. After clicking my y equals button, I'm going to type in that equation. So I'm going to type in y equals x squared minus 3x plus 5. And then I'm going to hit the graph button. And what I'm trying to figure out is, where does this graph cross the x-axis? Those are my zeros. Those are my real solutions. So you kind of have three options here. And maybe this is what I would write on your note sheet. And by maybe, I mean this is absolutely what I would write. You are either going to have one solution, one spot where it hits. You are going to have two solutions, because there's two spots where it hits. Or you're going to have no solutions, because it doesn't touch your x-axis at all. No real solutions, really. Here's the thing. This graph, when you graph it, it's going to look something like this. It never touches your x-axis down here, so this one's going to have no real solutions. Now, if you're like, yo, Miss Sylvester, I hate graphing. It's the worst. You do have a second way you could do this problem. In fact, we just learned this in my class today. We learned about that thing called the discriminant. So this one works because I have x squared minus 3x plus 3. Remember, we learned about our discriminant, which was b squared. Oh, let's use an actual pen, not a highlighter. B squared minus 4ac. And you had three cases. If this was a positive number, then you're going to have two reals. If it was 0, then you're going to have one real. And if it was a negative, you'll have no real solutions. Or you'll have two complex. This one, if you plugged it in, if you figured it out, you should get no real solutions, because you should get a negative number as your discriminant. So if you don't want to mess with your graph and you want to use your discriminant, that's okay. But something I would write on my note sheet is that, hey, to find my real solutions by graphing, I can also find the discriminant. That's a note that I would make, just so you know how to do it when you're stuck. Hopefully I don't need to write that on my screen. Hopefully you can rewind and listen and write that down. All right, my next one says, what are the zeros of the function and what are their multiplicities? Again, the easiest way to do this is probably to graph it, but I think you can factor it too, so we're going to try that. And if that doesn't work, we'll just, retape this whole slide. No biggie. The first thing I'm going to look for if I'm factoring is a common denominator, or not common denominator, a greatest common factor. What's the thing that can go into all three parts of this? I noticed that they each have an x, so my GCF is going to have an x. And then I noticed that my smallest number is 3, and I can divide 3 by 3. I can also divide negative 18 by 3. So I'm going to have a 3 out front. Now I'm going to erase this just so I can see what I'm doing here. But we're going to divide each of those things by 3x. And write the leftovers in parentheses. Now 3x squared divided by 3x is just x squared. 3x squared divided by, or 3x cubed, for the first one. 3x squared divided by 3x is just a positive x. And then negative 18 divided by 3 gives me a negative 6, and my x's cancel. Now at this point we have 3x out front. We have x squared plus x minus 6. Now hopefully we can use the x method to factor this guy, so let's try that. We're looking for something that multiplies to negative 6 and adds to 1, because that's my number here. My two factors are going to be 3 and negative 2. This guy is still part of my answer, so I still have 3x. And then I have x plus 3. And I have x minus 2. And we're going to set it equal to 0. Now at this point, we're going to set each part equal to 0. So I have 3x equals 0, x plus 3 equals 0, and x minus 2 equals 0. And we're going to solve for x. For my first one, we can divide both sides by 3, and we get x equals 0. My next one, we can subtract 3 from both sides, and we get x equals -3. And my last one, we'll add 2 to both sides, and we get x equals 2. Now we found our zeros, which is what they wanted, but we need to talk about their multiplicities. Multiplicity is the number of times the zero shows up. And we just factored it, and we had x equals 1 showed up once, x equals -3 showed up once, and x equals 2 showed up once. So I would say that all three of these have a multiplicity of 1. Now if we had another like x equals 2 here, then these guys would have a multiplicity of 2 because it showed up twice. But none of them showed up more than once, so it all just has a multiplicity of 1. All right, my next one, we have x squared plus 6x cubed plus 8x squared. For this one, we're going to try to do it the same way, factor out a GCF. We can divide each of these by x squared. So we're going to have x squared out front, and then in parentheses, we would have x squared plus 6x plus 8, excuse me. Now at this point, hopefully I can factor this guy. I'm going to set up this guy. We're looking for something that multiplies to 8, adds to 6. It's going to be 4 and 2. So I have x squared times x plus 4 times x plus 2, excuse me. And all of that equals 0. So now we can set each part equal to 0. X squared equals 0. X plus 4 equals 0, and x plus 2 equals 0. Now my first one will take the square root, and we get x equals 0. Now this one's special though, because look, your exponent here is 2. That means that this one has a multiplicity of 2. To be quite honest, it's our only interesting one so far. My other ones will subtract 4 from both sides. We have x equals -4. My second one, we have -2, x equals -2. Now again, my second one's only showed up once, so I would say each of these guys have a multiplicity of 1. Again, if they had an exponent on the outside, so if there's a squared here, or we had like a duplicate answer, then it would have a multiplicity different than 1. My last one says, what are the zeros of the function? Graph the function. Good news, it's already factored for us, so that makes everything grand. We're going to set each of the parts equal to 0. So we have x plus 2 equals 0, x plus 3 equals 0, and x minus 4 equals 0. Now to get rid of our 2, we're going to subtract 2, so we have x equals -2. My next one, we're going to subtract 3, so we have x equals -3. And my last one, we'll add 4, so we have x equals 4. We need to graph this guy, so I'm going to go ahead and plot my points. We have a -2, a -3, and a +4. We'll do it in red. So I have a point at -2, a point at -3, and then I have a point at 4. Now I notice I have x, x, and x, so I'm going to end up with a positive x cubed, excuse me, at the beginning of this. If you're not sure which way your graph goes, type it into your calculator. I would put all of this into y equals so I could see, but because it's going to be positive, it'll go that way. So it'll look something like that. Again, use your calculator to check your answer, or use your calculator to just tell you the answer and find the one that matches the graph. Totally up to you.